All right, this video is going to cover 1101B, which is the algebraic way of finding these inverses. So let's get started. Basically, if you see this word inverse, you're going to switch x, y. That's critical to know. So also realize f of x is y. It's the same thing. So when you switch, like number one, you're looking at x equals y squared plus 4. Now the key to these is solve for y equals. You need to be solving for y equals. So what that means is you want to isolate this y here. Well, you have a plus 4. You have to get rid of that. So now you're looking at x minus 4 equals y squared, but that's still not isolated yet. You have to root it. When you root it, it's plus minus root x minus 4. But let me just go ahead and write it out. But this was a quadratic, and if you remember from graphing these quadratics, here's original. We'll do original in green. So here's original. If you did the full inverse of this as if it was plus minus, it would be like this. The total red, and that's not a function. It doesn't pass the vertical line test. So they'll tell you to restrict the domain for all quadratic functions. What that means is you need to choose either plus or minus. We're going to go with the plus. And so what that means is on this original, we restricted the domain to be, we cut it right here, and we restricted the domain to be just this orange piece. Just all these x's that were greater than or equal to 0. That was our restriction. And by doing that, we end up with the positive of the root. You could have, if you wanted to, you could have restricted it to like pink here, and that would have been x less than or equal to 0, and it would have been the negative version. So just keep that in mind, but we restricted it to the positive. All right, next up, number 2, switch your x and your y. Now go solve for y, so minus 1. And then divide by 3. Oh, and it's not y equals, it's y negative 1. Y negative 1 equals. That means inverse. Now, you could either leave this as x minus 1 over 3, or you could break up that fraction if you wanted to call it like x over 3, which is like 1/3 x, and then minus 1/3. It doesn't matter. Either one of these equations is correct. Okay, number 3. Switch your x and your y. Now go solve for y. So you need to cancel this square root by squaring. And then add your 3. So you end up with y to the negative 1 equals x squared plus 3. Okay, this next one. Switch x and y. Square root it. Subtract 1. Now be careful that when you subtract this 1, it does not go inside that root. It's outside the root, like this. Okay, and this was another quadratic, so if you think about the original, x plus 1 squared, we'll do the original in green again. X plus 1 squared looks like this. And so what we got was root x minus 1. Looks like this. So we restricted the domain to just be this orange section, aka all the x's that were greater than or equal to negative 1. This was our restriction. You could have done it the other way, but we went with the positive version of it. Okay, moving right along. Find the inverse of this. Switch your x and your y. So now you're looking at x equals y minus 3 squared minus 4. Add 4. Cancel the square by rooting. And then add 3. Now when you add 3, it has to stay outside. So it's going to be like this. When I say outside, I mean of that root. So it looks like this. X plus 4 is in the root, and then the plus 3 is outside. So my answer here would be A. And yes, you need your plus minus as well when you root something. Okay, moving right along. Switch XY. Cancel the root by squaring. Subtract 7. The next one, switch XY. Cancel the root by squaring. Divide by 3. The next one, switch XY. Cancel the cube root by cubing. Add 5. The next one, switch XY. Okay, you need to take care of the 1/5 first. So you're going to times it by the reciprocal, 5 over 1. So that's how I'm going to get this 5x on the left side. Now over here, what happens is the 5's cancel and the 1's cancel, and it just leaves y cubed. And then to cancel that cube, now is when you cube root it. So you end up with your inverse is the cube root of 5x. Okay, now this number 11, they're giving you the equation for surface area of a sphere, and they want you to solve for r. So they tell you the surface area is 1017. 1017. All right, so you basically have 1017 equals 4 times pi times r squared. So let's start out by dividing by this 4 pi. Because when you do this, these will all cancel, and then we'll just be left with this r squared, which we can root to get the answer. So let me punch this in the calculator. All right, I got 80.9 is equal to r squared, and then you're going to root it. And so this is basically like 81, right? So my answer would be r equals 9-ish. So that's what this means. It means roughly equal to. So my answer would be B. Okay, and then this last problem. Solve the equation r equals root p squared plus q squared, and you're solving it for p. All right, so what this is going to look like is you have r equals root p squared plus q squared, and you want only blue, okay? So to get there, cancel the root first with a square. So now you have r squared equals p squared plus q squared. You're going to then subtract q squared. They are not like terms, so you just leave it r squared minus q squared equals p squared. And then you want to cancel that square by rooting. And you need your plus minus when you root something. And so this one, I would end up with p equals the plus minus root of r squared minus q squared would be my answer. So that looks like D. Okay. So yeah, that is how you do inverses algebraically. They're not that hard. Just switch your x and your y and then go solve. So if you're good at algebra and you're good at solving, you should be good at this. Hope this video helped.